Hello students, in this video we will be learning about stability for LTI systems. The third, stability for LTI systems, and in this also we are going to get the condition on impulse response if the LTI system is stable. Okay, before moving into the getting the equation of impulse response in for a stable LTI system, then what is a stable system? Okay, whether it is LTI system or not. So, what is a stable system? A stable system is a system it produces a bounded output for a bounded input. If a system produces a bounded output for a bounded input, then that system is said to be a stable system. Let us consider there is a system. So, and if you give a bounded signal as the input, if you see, I will tell you in a moment what is a bounded signal. So, you are going to get bounded signal output. So, when it comes to the definition of a bounded signal, so what is a bounded signal? So, bounded signal has got some limitation. So, whether it may be a positive value or it may be a negative value. So, but it should be a finite value. So, let us consider, and it should not go up to infinity, it should not increase exponential or any other way. So, let us consider, let me explain some of the bounded signals. So, let us consider this is a unit step signal, and the maximum value of this unit step signal for all time t, so that is 1, and for all time t the minimum value is 0. That means it is bounded between two values, that is +1 and 0. And this is an example for a bounded signal. Let us come to the another signal. See here, this is also a signal. So, if you take at any time t, so for all values of t, so for example, this is 1 and this is 2. Okay, so the maximum value is 2 and the minimum value is 0. So, this means this is also a bounded signal. Okay, so coming to the unbounded signals, let us consider this signal. So, here this signal is exponentially growing and it will go to the infinity at time t is equals to infinity. So, this is an example for the unbounded signal. Okay, a ramp signal is an unbounded signal. This is a ramp signal and this is an exponential signal, and these two are all unbounded signals. From mathematically, how do we express that bounded signal means? Let us consider, so modulus of x of t should be less than or equals to some value of, let us consider some bx which is less than infinity, where b is something as positive quantity, positive value. Okay, modulus of x of t means at the positive y axis and the negative y axis, and the maximum value will be bx, and where bx is less than infinity. If any signal satisfying this equation, this is called as a bounded signal. Okay, remember that this is a bounded signal. If a bounded signal, if you are going to get the bounded signal as the output. Okay, so bounded signal. So, if I give this a signal as the input, if I am getting the modulus of y of t less than or equals to something by, so by is something which is less than infinity. This is a bounded output and this is a bounded input. If this happens to any system, then that system is said to be a stable system, otherwise the system is said to be unstable system. Now, we will derive the condition for the stable system in terms of impulse response. By looking into the impulse response, how can we verify, we can say that the system is stable or unstable systems. Okay, let me go with the equation once again. The response of the system, so let me go with the yfn is equals to, so we can write this as h of n convolved with x of n, that is the output of the system of an LTI system is given by the convolution of the input and the impulse response, that is equals to summation k is equals to minus infinite to infinite h of k x of n minus k, h of k x of n minus k. So, let me take the modulus on both sides. So, this is yfn, let me take the modulus of yfn. So, modulus of yfn is equals to modulus of summation k is equals to minus infinite to infinite h of k x of n minus k. Okay. And from the properties of modulus, we can write from the properties of modulus, modulus of x plus y is less than or equals to modulus of x plus modulus of y. This is from the properties of modulus. And from the properties of the modulus, we can write this modulus of y of n is less than or equals to summation k is equals to minus infinite to infinite modulus of h of k modulus of x of n minus k. So, we can